Okay, great. Today we're going to focus on the application of differentiation, and next week hopefully we will finish the integration and application of integration. So we'll check how that goes, and then we will have enough time to also do some prep work before you write exams. So we will work through previous exam papers, previous assignments, all those kind of things, so that we can just make 100% sure you get enough practice in enough different questions that they might ask you, that you just see enough of that. Okay, so in today's session we basically continue where we left off last week, and that is we looked at all the differentiation rules, but now we're bringing, as in our when we looked at the linear lines, we're now bringing in something with the differentiation component as well. So things that we will need to look at and be able to do is we need to be able to explain what is average and marginal revenue cost. Then we will use differentiation to optimize. So just like we did with the previous sections, we will try to look at the revenue, cost, and profit functions and see where there's a maximum or minimum. And then, because this is now going to be a non-linear equation, we also need to be able to work out elasticity. So remember, way back at the beginning, we had worked out elasticities for linear regression lines. Now we will need to work out elasticities for non-linear. So elasticities for a graph that might be a cube or quadratic or anything like that. So we will need to work out elasticities for non-linear graphs as well. Okay, so first thing, and this I've taken straight out of your books, but it is a nice one nearly to show what we will need to do. So when we have a normal total revenue, total cost, fixed cost, variable cost, and we differentiate, we will get the marginal revenue, the marginal cost, and the marginal variable cost. Okay, so nearly if you get the total value, so total revenue, total cost, fixed cost, variable cost, if you differentiate, you will get the marginal values. The reason again for the fixed cost, so most likely the fixed cost is a constant, and let's say that constant is 2000. We know if we differentiate a constant, it will become 0. So the fixed cost will never really have a component that is differentiable. Okay, so we look at marginal revenue, marginal cost, and marginal variable cost. Then just to add on to that, to get to the averages, we will just divide by Q or divide by price. So depending on what we will need to find out, the average we will just divide. So we will have again, some examples that we will look at, but this is a very nice diagram nearly to remember, because when we get to integration, we're just going to do the opposite. So in integration, we're going to get the marginal revenue, and we will need to work out the total revenue. So that is still coming, but just we will then again use this graph just to show that differentiation goes for one way, integration goes the other way. So then just again, I add this so that you can get the fuller picture, and sometimes they ask questions on definitions, or like have one question where they just throw in a few definitions and you need to pick which one is correct or incorrect. So I just added what is marginal revenue, the definition, and if by any chance they are something, but this is really more on the economic side. But I thought let's just add in some definitions of marginal revenue. And basically what it means, it's the increase in revenue that results from a sale of one additional unit. Okay, so marginal revenue will basically be what will it the increase in revenue be if you sell one more additional unit. Okay, so it might be that at a stage marginal revenue becomes negative, and then you don't want to sell additional units, because then it might mean that your revenue will come down. So that's nearly why we have a marginal revenue function, is to work out what is that extra cost if you increase production yearly. What will it be? Or what will the revenue be? Then the same for marginal cost. Here we're looking at the cost structure. So change in total production cost that comes from making or producing one additional. So remember, revenue is linked to income. So what will one extra unit do to income? And then what will one extra unit do to cost? And then there is hopefully the one that talks about your average revenue versus marginal revenue. So you can just see your average is total revenue divided by Q, where your marginal is that change in total revenue divided by Q. Okay, so also just the big difference between the two, and that is going to be the same with your cost function. Also, the difference is nearly average cost will be your total cost divided by Q. Your marginal cost will be that change in the revenue or the cost divided by Q. Then I've added this, but I haven't seen this really in your assignments. So they talk about productions functions around labor, and this one basically looks at elasticities of labor, but yeah, I haven't. I see they talk about it in your study guide, but I've never seen that they nearly ask a question around it. So it will also be interesting to see if I, in any of your assignments, alluded to this or have anything in the assignments around this. Because I think that will be quite interesting because yeah, I've added it, but I really haven't seen anywhere in the last 2 years nearly that they've asked something around it. And then the important thing that will definitely be part of your exam. So there will always be a question on elasticity of demand for linear, but there will also be elasticity for nonlinear. Okay, so very important that we know this. But what's also great is, again, you writing open book exam, so you don't now need to go and learn this function off by heart. We will use it as it's needed in the question. So when a question like this comes up, I will just copy and paste that function in, and we will work with it. So you don't need to go and learn these things off heart. I also will send you guys, I've made summary pages of all the study units with the important things that you need to know about each one. So I will try and scan that during the weekend or the week and send that to you guys as well. That you have that. It's a few pages of things that I thought is important. Okay, so again, you will get a question around this in the exam. So let's nearly go straight into it, and you will see that most of the things I also have given you the answer set or how it was worked out. So let's look at this first one. So the demand. Sorry, I've got a bit of a cold. The demand for tickets to the Soccer World Cup is given by this function, where Q is the number of tickets bought and P is the price per ticket in hundreds of rand. Okay, so they give us that function. Find the expression for price elasticity of demand in terms of P. Okay, so all that we need to now look at is, let's write that down. So where was elasticity of demand? So let's just see, it is exactly the same. Change Q, change P times P over Q. Okay, so let's just copy that in. And again, you don't need to remember these formulas off by heart. You just need to know which ones to use. Okay, so we've got price elasticity. Okay, what's going on here? Let's just take that away. And let's just go back to that one. Let's just do this one. And the important thing with this is to remember in terms of P. Okay. So if you look at in terms of P, we need to change this formula a bit. So let's just make sure that we got this right. So the first thing is differentiate this formula. So if we differentiate this formula, the 192 will fall away, and there we will have minus 2p. So just remember from last week, if we differentiate 192 because it's a constant, then the 2 goes in front. 2 minus 1 is 1, so we can just take that away. So that's why we have minus 2p, is because of that differentiation. Then we need to rewrite this. So we've got p at the top. No problem with that. We've got q, and q's formula is 192 minus p to the power of 2. Okay, so and now it's one of those things that in this instance you would need to look at the solutions that was given to you. This stage, that could be a final solution, but they might want you to multiply that one in so that you get to this stage. So this one is nearly more important to check what is your answer set, because I would not have had a problem if this was the final answer, but they might also want you to go to really the final one. So when you get to this point, please, and remember multiple choice, so you will never need to just write out the answer. You will need to pick one of the solutions. So at this point, please merely look at what the solutions is. So if you get this, you don't need to go and simplify more. So it's more just for you to check which one is one of the options. Okay, because both are correct, but again, let the answers nearly guide you. I just want to check if I have a question in here that is, it's all okay. So here I will also show you that you can see there's a few different types. So question 11, we will definitely get to see that. Okay. So let the option set nearly guide you into going into that final answer and how far you need to go. But question 11 we will use as as that. Okay, so now one can also get other questions around that. So so for questions B and C, I have included it because question B, you're now just going to replace in that formula your pricing, and you will get the elasticity, and then we're basically going to ask around that elasticity. So then it becomes just like we did in the first chapter where you analyze the elasticity. So it can be elastic, it can be inelastic. So yeah, so for B and C, please try it. We can always chat on the WhatsApp group. So again, no problem to chat on these problems on the WhatsApp group. That is also why it is there. So yeah, please check if you can do it. So yeah, I think the one thing to look out for in question B is in the formula they say the price is for P is the price per tickets in hundreds. Okay, so what will happen is they will ask you a price of 800 Rand, and then if you added 800 in this formula, you will get an answer, but because it is in hundreds, you should have put in 8. Okay, so that will then give you a different answer. So go and test it, be careful. Then I just recopied all of the formulas of last week, where we look at all the rules for differentiation. These ones, the top 3 is the ones that we use the most. Okay, the constant rule, the power rule, and the product rule. Those are the ones that we really use the most. It's very seldom that we get one of the others, but I have also for our exam prep, I have definitely have a few of the others that we will go through for the exam prep, that we just make sure everything is covered. Okay, so here we have one that's a bit different. And again, we're gonna first try and do the marginal revenue. And you can see this is a function within a function. So we're first gonna work out marginal revenue, and then we can look at if we need to do anything else. So first, I want you guys just to quickly grab a piece of paper if you have. Check if you can get to do that first one, where we need to find the marginal revenue function. There is the formula sheet, or the formula for the differentiation. Again, you guys don't need to know all the differentiation rules off by heart, because we have it in our study guides. It is open book. Okay, so let's look at this one. So marginal revenue. So remember, if we need to get from to marginal revenue, we need to differentiate total revenue. So the first thing we will need to find out is what is that marginal or that total revenue curve. Okay, so, and that is the first thing that nearly is the thing that can catch us out. So if you look at that, we've got the demand function, but we also need to, for total revenue, remember that is P times Q. Okay, so we don't forget the Q. So we can't just now take this and work out the marginal revenue on this. We will first need to get to the total revenue. So total revenue is P times Q. We've got the P, so remember, then it looks a bit different. So we need to add that Q as, I'm going to try and move this now over. Let's quickly see if I can do that. It's not just, okay, cool. Okay, so first thing that's important is that we've got the demand, the price for total revenue. It is price times Q, so we need to bring in that Q into the calculation. Else, again, we are going to have it when we start differentiating, that suddenly that Q we would not have had in it, and then that does take away some of the information that we will need to have later on. Okay, so let's quickly just copy this in, that I can show you guys how to go through it, and then, as always, the other components of this question that you also can look at. So let's just quickly check that is exactly the same. The Q doesn't matter where it sits in that first component, as long as it is in that first component. You don't want to add it to the back, because that just makes it sometimes a bit more difficult to work with. Okay, so now we need to differentiate. So remember your differentiation. It is the differentiation of the first one times the second one that we keep the same, plus the first one that is then kept the same, times the differentiation of the second one. Okay, so let's first, they've already combined it there, so let's first do it on its own. So we've got that one. So if we say Q, there's Q1, the one will go in front, Q1 minus 1. So that's why in the first one, there's actually not a Q left. And then remember, we write that second term as is, because that's what we do. We write it then we take differentiation of the second one. So fx we just write as is. Okay. And then we differentiate the second one. So if we differentiate that, that will go to the front. And we will keep that. I will try to move this again in a lot of small numbers. And let's just quickly see if I can move this in again. Or let's move that to the one side and move that in. Okay. And now if we want to get to this component, so again, they have skipped. So let's just take 1500 out as common in both. Then what's left here is e to the power of minus 2,025 q, and that you can see there. So here we take out the q, and we left with 0,025. So remember that q goes out. E. Okay, so they basically with this one just skip that initial step. So again, what you need to do in the exam is you just need to get to that final answer. So they don't really mind how you get to that final answer. So now we have the 1,5. Here you can see we can take that component out as well. So then we will be left with that, and this will be replaced with 1, and this will replace by minus 2 or 0,025q. Okay, so again, important to look at your options, because that might have been the final answer, or that might have been the final answer. So just again, nearly first look at your final answers to see how far you need to simplify. Okay, so then what they will do is they might ask you you now have a marginal revenue. So if you say the marginal revenue is a certain amount, you can work out what Q is. So you will see BC is now nearly practicals around that marginal revenue. What is important for you guys also, we're not going to do this in the exam. Yeah, if you can hear me. Okay, it seems like I am back. Cool. Okay, that was weird. Um, cool. Okay, so just remember in the exam, they will not ask you a question like this where it follows up on one another, because if you made a mistake in the first one, then all the rest is also wrong. So it's not like in the pre-COVID days where they would have been able to mark with your mistake and those kind of things. So they will not ask you a question that follows up on a question. Okay, so but go and look at question B and C, because it is quite interesting questions to look at. Okay, so let's go and look at, this is more the questions you will get where there is an option set for you that's available. So if a demand function is P is equal to 40 minus Q, where P and Q are the price and quantity, give an expression for the price elasticity of demand in terms of P only. Okay, so let's again, I want to take that elasticity formula. So we will always remember, you will always have all of these things available. So remember that you are allowed to use any of your study notes, any of the things I've shared. So when we get to the assignment prep, you are allowed to use all of those documentation as well. All your own study notes. You're allowed to use calculator, allowed to use Excel. Okay, so they want us to look at price elasticity of demand in terms of P only. Okay, so let's look. And so that is the price function. So we first need to change this function, because I want to replace the Q. So if I want to get to the Q, the 40 will go to that side. So P minus 40 is equal to minus Q. So then I want to get rid of a minus. So on this side, it's actually 40 minus P is equal to Q. And then let's put that back into the formula. Sorry, I want to move this again. Let's just see. Okay. Okay, so first let's look at what is minus B. The minus B is actually minus 1. So there, that component will be equal to 1. Then times P over, and now it is P minus 40. Okay, so 1 times that then stays P over P minus 40. And so let's look P minus 40. Okay, it needs to be at the bottom. So that one is not correct. P is right there. 20 minus a half. So no, that's not right. P is right there. 20 minus P is not right. P is correct there. P minus 40. So option 4 is the correct one. So let's just see. And if we work it out, we can see it is option 4. So this is more how your exam will look like, where you can already nearly see in this instance, okay, where did I now suddenly get 2p? Okay, there's not really, so unless you maybe set, yeah, I don't know how we would do that, but so they brought in 2p there. There's nearly also, so nowhere, it was only in that one where there was a 40, which might throw you off, but all the other ones was definitely wrong. Okay, so nearly let okay, so let's quickly just want to see if I don't have to see if I've got something like that. Else I would look for a question like that for you. I will look for something like that. Then I will bring it in next time. Um, you will nearly do the same process, but it might be that somehow in it they might have that something cancels out or something like that. So let me just write it down that I will look for a question like that where it is a quadratic. I will also even look if there might be a cube one as well. Because please, if you have that question, pop it on the WhatsApp group. If you still have it, then I can look at it. Because it's always nice also just to see what the answers is that you work in a certain direction. So please pop that into, or even into this chat if you can, but else on the WhatsApp group, and I will pull that into a presentation. And that is nearly for any questions you guys want me to look at. Please send it to the WhatsApp group, put it in this chat. No problem for me to use it in exam prep for you. Okay, so let's look at another question, and let's see how we need to address this one. So after training a new employee will be able to assemble, according to this formula, units of a product per day, where T is the number of months after an employee has started working at the factory. Approximately how many months after the employee has started working at the factory will she or he be able to assemble 40 units per day? Okay, so I included this one specifically because when we look at it, we're wondering, okay, but what must we do? Must we differentiate? Must we and nearly need to put it into the integration problems as well? But this is a very nearly one where they want to catch you out. So they tell us the quantity. So they tell us that you need to be able to do the 40. So the rest of the formula is actually, we just need to work out what the T is. Okay, so the rest of the formula is there. So we don't need to differentiate or anything. We must basically solve the T. Okay, so, and I've seen it where they love to do this in the exams, is they give you one differentiation question, they give you one integration question, and then suddenly they put in something like this where you then think, oh, is it integration? Is it differentiation? But actually, it's none of the two. You must just actually solve the T value. Okay, so then the 50 will go over to the left. So 40 minus 50 will be minus 10. Minus 10 is equal to minus 30 e to the power of 0.05 t. Then we will divide on both sides with minus 30. So minus 10 divided by minus 30, that will basically become a third. So we can take that away. E minus 0.05 t. Okay, so now it's more around what we did in chapter 3, I think, where we actually now need to work out a E function. How we do that is we take logs to both sides. So log of a third will mean that we can sit on this side with 0.05 t. So that is the rule. So just also check here that ln of a third, and there it is, the other one. So that basically means that we sit with t is equal to ln or log a third divided by minus 0.05. Okay, so there it is, so that we basically work out. So also, again, just a reminder, on your calculators, on mine, there's a ln, that's ln. some of your calculators will have log. It is exactly the same thing. So if we need to work out the linear third, we will put in 1 divided by 3, then take the log of it, which is minus 1.1. If we divide it by 0.05 negative, I get that the final answer is 21.97. And let's just move this component. Okay. And let's just quickly, so they want us to say approximately how many months? So I would have then said approximately 22. And so again, just be careful. I hope they don't do it, but you suddenly have a 21, 22, where they don't expect you to, but it might, in certain instances, they might want to test two things in a question like this to see if you round off to the correct day, and that you can use your log and exponential functions. But hopefully they will not have 21 and 22 as answer sets. But just always remember, if I say how many days, that it then is approximately 22. If it was to work out how many units completed, then we would have said 21, because you can't have a 0.97 unit or 0.5 unit because it's not completed. Okay. So just be, question 17 was definitely a catch question because it was thrown in between the differentiation questions, the integration questions, and suddenly your mind is also nearly want you to take you to that. So that is why I included it. Okay, so then we go into another one. So here we've got a demand function where P and Q represents price and quantity. At what value of P is marginal revenue equal to 0? Okay, so first we need to get total revenue. Total revenue is P times Q. So we will get total revenue first as P times Q. Okay, so important that so that we can get the total revenue function. Okay, so that's total revenue. So to get marginal revenue, we need to, marginal revenue is equal to differentiation of total revenue. So goes to a front, so it will be 150 minus that goes into the front, so 0.5 times 2 is 1. P2 minus 1 becomes P, and this they say at what value of P is the marginal equal to 0. So minus P is equal to minus 150, and P then is equal to 150. Okay, so what they could also have asked us in a question like this is, now that you have P, what is the value of Q? And so then we will replace P there with 150. So that's 150 minus 75, which will give you 75, which is also in that set. So again, just be careful. If you worked out Q, there is also an answer for you. Okay, so, and what they might ask is the P and Q value and say P is that, Q is that, or there might be one like that, and then some other options as well. So they might also just bring in both of them into the answer set. Okay, so that you need to know just so that you need to know that how to work out Q if that is also asked in the question. So you can work out the P with the differentiation, but they might just ask you how to work out the Q as well. Okay, so that is a question where we look at a marginal revenue that we have differentiated the total revenue to get to that marginal revenue. And again, if you just want to get the steps a bit more formalized, included in this pack is that as well, and I will share as always after the session. Okay, so I think some of these questions I also included last week to just show the practical aspect of a differentiation. So again, very important that we can link the two together. So let's look. A company's profit function in hundreds of thousands of rands can be represented by this function, where X is the number of units produced. What is the value of a company's maximum profit? And this is quite an interesting question. Company's profit function is represented by this, where X is the number of units produced. Okay, so if we would have drawn this just quickly, and I might be totally wrong, where it crosses, but it goes down because that's negative. So that is 7. So somewhere here we have a maximum profit. Okay, if I look at this graph, I would have automatically said, well, there's 7, so between 7 and 16 will be my answer. So it might be that that is also where the curve ends, else it will be higher. So I would have guessed one of those two. I have not worked it out, but that is what I would have guessed. Okay, so we want that turning point. So we can do two things. What was it? Last week or the week before, we looked at that x turning point, where I think the formula was minus b over 2a. So minus b, and let me just see if that is minus b over 2a before we now where is my notes? See, I also can't remember just off by, I think it's minus b over 2a. Yeah, minus b over 2a. So minus b over 2a, a is 1. Okay, so that is 3. And so there they give us 3, but we need to work out the profit. Okay, so we still need to then put that 3 back into that formula. Yes, we can. So we can definitely, and that's so I want to show both of them so that we can just see again that you guys can use the one that's the easiest for you. So 3 to the power of 2, so that is minus 9 plus 18 plus 7. So that will give us 16. Okay. And then we can also differentiate. So you can differentiate that and set that to 0. So minus that. So why I wanted to show you both is so that you can decide which one is the easiest for you to do. So if you differentiate that, it becomes minus 2x minus 2x plus 6 is equal to 0. So minus 2x is equal to minus 6. X is equal to 3. So again, you get the same value for x. And then you still need to put the x into the y. And then you will get the same answer as 16. So just because it is a quadratic, are we allowed to use this turning point function? When it's cube, you can't do it. So cube, we would automatically go and differentiate. Okay, so there you can see it doesn't matter which method you use for a quadratic function, it will give you the same answer. Okay, so that's why I just wanted to show you that you are able to do it. So when you're in a panic and you think, oh, is it differentiation? Is it turning point? It's actually both. Okay, so and both will give you the same answer. So it's not that it is a train smash if you suddenly use a different formula. You can see that, yeah, it is giving you the same results. Okay, so the the last one for today. So again, wanted to put in a quadratic one here. So total cost is given by this. We need to get marginal cost. And then we need to get marginal cost when Q is a specific number. So first thing, if you put in 10 into this function, you will get an answer. Okay, so if you put 10 in this original function, you will get that answer. So they always make sure that if there is a question that you might be thinking about, might want to do differently, there is an answer, unfortunately, that will be wrong. So first, we will need to differentiate. So to get to marginal cost, we need to differentiate the total cost. So the 3 goes to the front. 3 times 2 is 6. 6x, 3 minus 1 becomes 2. Then minus 2, okay, and I set x. Now you can see how I am always want to nearly write down x, so that was 6q. Okay, so minus 2q, and then here the q falls away, so we sit with plus 80, and 150 is a constant, so 150 becomes 0. Okay, and then we can substitute the 10 in. So 10 times 10 is 100. That is 600. 2 times 10 minus 20 plus 80. So the answer is 660, which is option 3. Just also take note that sometimes one of the answers might be 700 because they want to check if you've done this correctly. Because if that was a positive, then it becomes 600 or 700. So sometimes they will also check if you've done that minus that 2 that you brought in there, if you still kept the negative sign. So just be very careful with that you keep your signs correct, because that might even also be one where they bring that into the formula. Okay, so that nearly show you guys the context of the application of differentiation. And again, the whole question has been written out for you guys as well, that if you just want to follow it again. But very important in this one, just check if you have put in 10 in the original. 10 to the power of 3 is 1000, times 2 will go there. 10 times 800, or 80 gives you the 800. That would have been 10 times 2. So 150 minus 100 gives you the 50. So if you have made that mistake, unfortunately, there is an option for you. So yeah, just again, be very careful when you look at this, so that you don't make that mistake. There's even, and again, just want to show you, so if you set the next made it the second differentiation, look at that. So the 2 will go in front, so it will be 12, and then that will be minus 2. So if you then replace it, you will get 120 minus 2, which is also an answer. Okay, so if you used it as this, there's an answer. If you did it and you said total cost differentiated one time, you will get the 660, which is the correct answer. If you say total cost and you differentiate it the second time, you will get 118, which is also the wrong. So just be very careful with these questions, because nearly for everything that you could have thought of, there is unfortunately an answer, and that is also sometimes a bit scary. Okay, so that is it for today, everyone. So next Saturday we will focus on integration, and hopefully we can add the application of integration as well. That we can finish that off by next Saturday, and then we can start prepping for the exam. So please send me any assignment questions that you have that I need to add to that pack that we will work through to prepare you for the exam. Please pop it in a WhatsApp. You can add it into this chat as well, and I will bring that into our discussions, so that we can just work it out and get you as well prepared as possible for the exams. Okay, so that is it for today, everyone. I will share the presentation with you on our WhatsApp group. I will put the recording on the WhatsApp group, so that you have everything. It will probably only be this afternoon, but I will share both the recording and the presentation, and then I will also just scan it's about 5 pages of notes that I have that I just want to scan for you guys and send it on, that you have that as well as a backup. So it is from basically study unit 1 to the end. I've just written down some of the rules, some of the things that might be handy for you to just have when you do the exam later on. Okay, that is it for today, everyone. Have a great Saturday. Have a great weekend. And if you have off on Monday, have a great long weekend. Thanks, everyone. Cheers.